missing today? Anybody?
Jesus.
Nice. Nobody. We're missing Jesus, really?
Yeah, he's right there.
How do I compete?
I can play them up, Jesus.
Do you believe in Jesus? Or he was always my pastor. Do you believe in Jesus?
Let's keep it to math discussion for now, guys. Sorry, I don't want to get sidetracked. So, let f be the function on the closed interval from -3 to 4, with f of 0 equals 3. The graph of f prime consists of one line segment and a semicircle. So what is this the graph of again? The derivative. So first thing we write down, this is the derivative graph. It's so important that we note that. If you do this like it's the real graph, you're not going to get any of the parts right, or any of the parts right for the entire test. This is the derivative on this, okay? It's given as the derivative. Now,
It's negative.
we're also given an initial condition, aren't we? Initial condition of f of 0 equals 3. So we have the point 0.03 of the original function. I'll let you guys come up and do it again like we did last time. I think that went better, but I'm just going to write down the givens first. Okay, our domain is given from -3 to 4, which makes sense. Take a look at the problem. Okay, it's from -3 to 4. All right, let's talk about the first one. On what intervals, if any, is f, the original f, increasing? Kenneth?
From -2 to 2.
Very good. Why?
Because...
It's there. I know it's there. Sorry.
No, I was looking at
I
it.
know.
But like, since it's the graph of derivative, everything above the x-axis
Is
positive.
increasing, and below is?
Negative, decreasing.
Good. So everything from here to here, okay, all that stuff except for here, we'll talk about that in a minute, everything down here is decreasing. Everything up here is increasing of the original function. So the domain for increasing is from -3 to -2. Now, they use less than or equal to. Again, remember this thing we talked about? If you want to, write it like this, that is more than fine. And take a look, by the way. Something that really bothers me is this. They use brackets here, and then isn't that just less than? Shouldn't that be less than or equal to if they're going to use brackets? So don't worry about that for increasing and concave up and concave down. If you list the correct interval, obviously with the correct reason, justify your answer, okay? You're fine. Don't worry about bracket versus parentheses. Again, I encourage you to use parentheses, because to me, here, like at this point in time right there, that is not increasing nor decreasing. It's neither. It's a stationary point. Here, it's a stationary point because the derivative equals 0. So I would never use the bracket to include the endpoints there. Okay? So anyway, from -3 to -2. What is your justification, Kenny, in your own words?
Because every value over, I think every value over, all values over 0, or you can't say 0.
All values of f prime of x that are
Greater than 0
are
increasing.
good. So this function f is increasing since f prime of x is greater than 0. All the words you just said, right there, circled.
Thank you.
Okay? I'm just trying to help
I know.
abbreviate. So again,
What'd you say again?
Again, that's no problem. All values of x for which f prime of x is greater than 0, okay, what I circled there on the bottom left, f prime of x greater than 0, means that the function is increasing. Increasing. Okay? Yeah, just move it a little bit, Ken. Thank you. Questions on that part? That's part A. That was like the gimme part, you know? 2 points, I'll take it, sure. Pretty easy. Let's go on to the next spot now. Find the x-coordinate of each point of inflection of the graph of f prime, of f, sorry, on the open interval -3 to 4, justifying your answer.
Second derivative?
So we think about second derivative, right? Now, we already have the first derivative one, don't we? So we're really finding the derivative of the derivative.
Yeah.
Okay?
Yeah.
When? Yeah, again.
The critical points of the first derivative are the inflection points.
Very good, sir. That's exactly what I was about to say. Keep that in mind. Very good. Well done. Now, what Houston just said is exactly what we want to talk about. Remember the critical points? The critical points of the original function, that tells me when it's increasing or decreasing. So the critical points of the derivative tells me when it's concave up, concave down. Think about it. You find the critical points of the original, okay, to see when it's increasing, or, I'm sorry, of the derivative, to see when it's increasing or decreasing. You find the critical points of the second derivative, it tells me concave up or down. So look at your graph here. When do we have critical points? When the derivative equals what?
0.
0. But we want the derivative of the derivative. So when are there horizontal tangents, pretty much? We start? No. Okay, that's the problem we're having.
0.
Only at 0 and 2. Let me explain. Take a look here. What is the slope of the horizontal line there? The horizontal line is 0. It's not because it's at that point. Again, you want to know about inflection points, right? Inflection points. Inflection points only occur when the concavity changes. The concavity changes when the slope of the first derivative changes. Remember, slope of f is f prime. Agreed? Remember, the slope of the original function is the first derivative. That's what the derivative means. So the slope of f prime is really f double prime. So if I look at this graph and say, when does the slope change? The slope is negative, 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 negative. Then the slope is positive. Well, sure, it's flat there or undefined in that case. Then it's positive, 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 0. Negative, 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 negative. So the slope changed here and it changed there at those two locations. So those are the critical points for the second derivative. Christian.
Why is 0 still included? I mean, even though the slope changes, it doesn't exist.
Well, all we're doing right now is first identifying when the concavity changes. That's what we're doing first. Okay, where the points of inflections are. Then we can go ahead and look at our solution and say, let's classify them. Some as do not exist, some as equal to 0. Okay? Now, for this kind of a problem though, again, justification of your answer is the important part. So, what you notice is that f prime changes from decreasing to increasing at 0. So this function is going down, then it starts to go up. Then it's going up, and then what happens here, it starts to go back down. We don't know enough information about the second derivative's function to tell whether or not this will be a point of discontinuity. Again, all we know is this. All we know is that the derivative is negative here, it's negative slope, then it's a positive slope, then it's a negative slope. So if I were to graph on my second derivative number line, okay, my second derivative number line here, what I'm going to see is that I'm going to have a negative slope until I get to 0, then I have a positive slope until I get to 2, and then after that I have a negative slope again. What indicates a change in concavity or an inflection point is just a change in sign. So by default, even though we don't know whether or not this exists or not, it's a change in sign. So it's going to be an inflection point. Does that make sense?
Yes.
Again, an inflection point comes about from a change in sign in the second derivative. The second derivative is really just saying, let me look at the slope of the first derivative. Well, this is the first derivative. So just look at the slope. Negative slope. This is a draw your tangent. Remember we did this in the beginning of the year? Draw all of your tangent lines here. Those are all positive slopes, right? Until I get to here, then it's 0 slope. Right there, it's a 0 slope. Then it's all negative slopes here. There's the negative there. So negative, positive, negative, point of inflection, point of inflection. Again, because these are points of inflection of what? Of the original function. Do I have the original function though? So I don't know if there's going to be discontinuity just yet. Okay, I really don't. Because all I know is that the first derivative has a corner. But that does not affect whether there's a discontinuity or not of my original. There's definitely a discontinuity if you graph the second derivative, for sure, because of that corner. There's got to be a discontinuity there. But the original, you might not have it. Okay, we don't know. All right. That's parts 1 and 2. Anybody want to explain part 3? Part 3, or C, thank you.
Wait, find an equation.
Ooh. You can come up if you want to do it on the board too. Find the equation of line tangent to the graph of f at the point 0, 3.
If you close it from negative to I think
Say it one more time, Edgar.
I think the derivative of the neural right.
Okay. You're on the right track, but you're already given the derivative in the graph, Edgar. You're given it, right? So, Christian, what Edgar's saying is this. We need to know what the derivative is at 0 to find the slope, right? We want f prime at 0. But it's given. This is f prime. What's f prime of 0? What is this location?
-2.
Negative 2. So f prime of 0 is really just negative 2. So the slope of the line is negative 2. So you're done. Y minus y1 equals m times x minus x1. Or simply y equals negative 2x plus b, plug in 0, 3 to find b.
It's 2 because of the fact that it's a horizontal
Negative
line?
2. No.
Negative 2?
It's again, to find the slope of a tangent line, you need the derivative at a point. This is the graph of the derivative. So the derivative at 0 is the slope, but what is the derivative's value at 0? Negative 2. Again, this point here, Kenny, is 0, negative 2. But that's a point on the derivative. So they're telling us that when you evaluate the derivative at 0, you get negative 2. That's where this comes in. Therefore, the slope is negative 2. Okay? So you're utilizing the derivative's graph to help you make the line tangent. To help you make the line tangent. Yep. You can leave it like this, or you can do it this way and solve for b. I would personally do it this way, because now you got 0 doesn't matter, right? And then move the 3 over. But again, this is fine. You do not need to do any more work than that. Okay, you don't need to do any more work than the actual point slope form. Okay, you can put it into slope intercept form, it doesn't matter.
So it's y minus y1.
Y minus y1 equals m, or a, times x minus x1. x1 and y1 come from the original function always, 0, 3. Part D is the tough part. Part D is the tough part. Because you're going to use that fundamental theorem again. Okay, that one that we keep going back to. Let's look at part 3 to make sure we have our, they don't do any more than that. They just put the tangent line, and they put the derivative there equals negative 2, and the equation is all you get a point for. So technically, you don't even get a point for that, even though we wrote it down. You don't need it, but I would write it down still so I know what I'm doing. All right, let's look at the last part now. Looking at the last part, it says, find f of negative 3 and find f of 4. Show the work that leads to your answer. And this is very tough, because you're given a derivative, right? You're not given the original. So you cannot by any means just say, all right, well, the common mistake is this. People say f of negative 3 is 1, f of 4 is negative 2, I'm done. Like, come on, that's just too easy, right? That wouldn't make sense to be the answer. And again, you're given the derivative. That's not the original. So, what is the fundamental theorem saying then? Who can restate it or give it to me so I can write it on the top?
The integral of f of x equals dx equals f of b minus f of a.
Well done. What are the limits?
B in it.
Thank you. Okay. So again, the integral of like a derivative is the original. The way I've been writing it in class, if you guys remember, is this. That's how I write it, because I want you to remember that when you integrate a derivative, you get the original. This is what your textbook and the actual fundamental theorem says, but they are identical. Yep. Again, I would remember the bottom one though, because a lot of the time you're given the derivative, and you got to remember if you want to get the original value, you got to integrate the derivative. That's okay, but this is fine. If you use the capital F, this capital F in calculus means integral. That's what capital F means. We went over that months ago, and I didn't even hound on it because I want you to remember the second half. Okay? This is the same exact thing. So, what does the problem want from me?
The original.
At what point? What does it ask for?
Negative 3 and 4.
Negative 3 and 4, right? Okay. What do I know about the original?
The original.
Positive, negative?
Okay, it's got increasing, decreasing stuff, sure. What point do I know about the original? 0, 3. Right? Aren't you given this value right here?
Yeah.
So, wouldn't it make sense for one of these to turn out to be f of 0 because I know it's just going to be 3?
Yeah.
So I should make one of my limits 0, really. So let's make one of my limits 0 now. Put a 0 up top. What would the lower limit then be? Which one should I do as the lower limit? Negative 3, obviously.
Yeah.
Why did I pick 0? Because later on, I'm going to have this equal to f of 0 minus f of 3. And I know f of 0. This is given. This is given right here. This is given as the value 3. And the problem is asking us to find f of 3, right? Or, sorry, negative 3. So we can solve for f of negative 3 because we know this, and we can calculate the area under the curve. Remember the area? This integral here, whatever this answer is?
But it doesn't have an equation for it.
It doesn't matter. Remember, the integral is defined as the area under the curve. So take a look. From -3 to 0, what kind of shapes do you have? You've got a triangle here. You've got another triangle here. So if you want the integral from -3 to 0, just add up the areas, counting this as a negative, though. What is the area of this triangle right here, the small one?
It's -1 times 1 is -1 is 1
What is it?
half.
1/2. Good, 1/2.
Negative
So it's above the axis, so this is going to be an area of positive 1/2. So this integral here, I can rewrite it as 1/2 plus, and then whatever this is, as a negative equals this whole same thing still. What is the area under the graph now? This is 2 by 2, which is 4.
-2.
Half of 4 is 2, but it's below the axis. So this area is -2. And this is going to equal 3 from f of 0 minus f of -3. And then you just solve for f of
We didn't
-3.
need the formula for that. Really, you didn't really need to.
You
know
don't.
the equation.
The thing is, you don't have the formula. That's why it's a non-calculator. You're not given a formula to integrate. That's why they make these problems up. They're non-calculator problems. I'm gonna show you my solution. It's got all this written down. 4. So I started by saying that, by the way, my solution. Make sure it's f prime of x. You note that right away. And that's not factorial. It's me just being exclamatory.
Nice.
All right.
You're screaming at us, right?
So since we know f of 0 is 3, like we said, let's use the net change theorem from a to b when one of these is going to be 0. So I go from -3 to 0, like we said. We know that equals f of 0 minus f of -3. I can solve this equation for f of -3, and that's what I did first. So I took this f of -3, moved it over here as a positive, and I took the integral, moved it over here as a negative. So I had f of 0 minus that integral. Okay? Now, the integral is exactly what we had. The area of one triangle from -3 to -2 was just 1/2. The area of the other triangle from -2 to 0 was negative, a negative value again. So we're going to have 1/2 of 4, which is 2. But as you notice, where's the rest of the word? I just went into the answer. Now I went right into the answer. You end up getting 1/2 minus 2, which is -3/2. That's this part right here. And we had let me erase so you can see. We had f of 0 here minus the integral. So you're going to have 3 minus -3/2. Okay? Again, you're going to have 3 minus -3/2. The only thing that's different about what's on here now than before is I just moved the integral around.
Yeah, you should just give put the first one in there. That was something before you flush it.
And guys, it's the same answer. It's the same answer.
So did you move the 3 down?
Yes, again, all I did right now, the simple thing that I did was this. I solved for f of -3 initially. Okay, what you can do is the exact same thing, or you can go ahead and do this and say 1/2 plus -2 equals 3 minus f of -3. That's what we had before. And solve for f of -3 there. Either way, you're going to get 4.5 or 9/2. If you want to do that, and solve for f of -3 by itself.
I was just wondering, with the fundamental theorem of calculus, the way they wrote it, you said that the capital F's meant that like the derivatives.
No, the capital F meant the integral.
So that makes sense.
Capital F meant the integral. Lowercase f meant the original. If you put f prime, that's the derivative then, and then f is then the original. So it depends on your notation there.
I was gonna ask you, I was confused. I thought you said it was like the derivative. No, not derivative. Yeah.
Integral, that's what you said.
No. Yeah, no. I thought you said it was derivative, but then it was the integral, and I got confused. Thank you.
Again, though, either way, you're going to get this answer. The next part is the harder part. The second part of this problem asks us, find f of 4. So we're going to have to now integrate from 0 up to 4, because that's our limits now, right?
Can't you do negative?
So, as Edgar said, we're going to do integral from 0 to 4 of f prime of x dx equals f of 4 minus f of 0. That's my new net change theorem that I'm going to use. Why am I doing it this way now? What are you trying to find the second time around? F of 4. And Kerry, don't I know f of 0 still?
Yep.
That was given as 3 in the problem. So I put a 3 in there. The problem now is this, and this is what people get confused about. Geometry. You need to know the area here
What the hell is that?
and the area here.
That's
I brought this problem up the other day in geometry, or in Algebra 2. We were doing area of shaded region and probability of that.
Did they do it?
And this is what comes up. And they were able to get this easy. Not the rest of the problem, but how to determine that area.
Right.
So, here's what I would do.
They're equal.
Encompass this with a box.
I was thinking that.
Encompass it with a box. As Edgar noticed already, you're going to see that there's symmetry. So both of these shaded
There's
regions,
symmetry?
there's going to be, you have two,
Be symmetric?
there is symmetry, or they are symmetrical, sure. You have this shaded region here and this shaded region here that are identical. Okay, they both go down by 2, it's a circle. So if you found the area of that rectangle, what's the distance across the rectangle?
I don't know.
Four.
And distance down?
Man.
Well, the answer is going to be negative though, yeah. So we're going to have 8 for the area of the rectangle minus the area of a semicircle. Circle is pi r squared, isn't it?
Half.
So it's going to be 1/2 pi, but what's the radius? 2. The radius is here, right? That's the radius of the circle.
Cancels.
It's a distance of 2. No, it doesn't cancel. You have to square it.
Okay.
Then it can cancel afterward.
I'm sorry.
So this is the area of that integral. So the integral that you're about to replace up here needs to have this in front of it. But what do I have to put in front of the whole thing?
Yeah.
It's below the axis, guys.
There.
Negative.
Oh, okay.
In front of that whole
We
thing.
can just do it after the back.
No, absolutely not.
I know. 100.
So we get, that was a little too corny.
Yeah.
We get 8 minus, this looks like 2 pi. Oops. We get 8 minus 2 pi with a negative out in front. Okay, now, if I move the 3 over by adding it, take this 3, everybody, move it on over. So you put a 3 in the front here as adding. 3 minus 8 is negative 5, minus a minus is plus 2 pi. That is the value of f of 4. Okay? And it's in terms of pi. So the answer key, we're going to see negative 5 plus 2 pi, but I think they actually put a decimal. Let's see what they did. Oh, no, they didn't. They didn't put a decimal. They get negative 5 plus 2 pi. Again, our last answer was 4.5. That's right here. And again, it's just a fundamental theorem they're going through. That's all. Okay, but look, 4 points for this. 4 points. 1 with the difference of the areas, 1 using the fundamental theorem, 1 the areas, 1 the fundamental theorem
The
again.
areas.
What do they mean by the areas?
Yeah, what do you mean by
But
different
remember,
areas?
calculating the areas.
Okay.
They're giving you a point for each. Pretty nice. Or using, really you're using the areas as the integral. That's the point you're getting for. Calculating the areas is geometry, that's easy stuff. Okay? So let's look quickly if I did anything different on mine. I know I didn't, but just to be careful. I started here, f of 4 equals f of 0. Why did I start like this? Because I knew already that in my last part, where's my last part? Right here. Remember this part right here? I'm going to have integral 0 to 4 of whatever that is equals f of 4 minus f of 0. And remember, I'm trying to find f of 4, right? So I can just take my initial value and move it over as a positive. So that's what I started with here, instead of going back through the fundamental theorem again. I started simpler. I said, well, I'm going to have to move this f of 0 over anyway, and I'm going to get f of 4 by itself, so let's start by writing it that way. And then from there, we just calculate. F of 0 was 3. This was given as 4 times 2 is the 8. This was the semicircle. I subtracted those, got negative 8 plus 2 pi here because it was a negative negative. Again, a negative negative gives me the negative. That's that negative there. Why is it negative again? Who remembers?
Below the x-axis.
Below the axis. When the area is below the x-axis, we have a negative value.
Under derivatives.
When the area is below the x-axis in general, and you're finding an integral, you have a negative value, just in general. Okay? All right, next problem I want somebody to come up and do. I don't want to do this one
I'm gonna
again.
try it, I'll probably fail at it.
Okay, this is a problem that we've done many times before.
Oh,
Related rates.
Okay, related rates.
Nah, I'm
Related rates.
I was right the first time.
Come?
Is it? No, I'm going to ask you something.
You guys.
Get me excited, you're coming up.
I'll try. I forgot.
I want somebody that didn't come up last time, though. You came up last time. I encourage you. It doesn't matter who, guys. There's like 8 people that didn't come up last time. Only 4 or 5 people came up.
You're right. It's birthday girl.
Oh, yeah, it's your birthday. Come on up.
I didn't know that. I was wrong.
I'll send you through.
You have a problem for your birthday. Technical support.
Like, yo, you just be
Guys, if you don't feel comfortable, I'll help you. I'm happy to help you. If you want to start it, just start it.
Jazzy, it's like a Key Spot commercial. Pull them out to the.
You have a question? Sorry.
Yeah, regarding the video, he said that this year they would definitely be able to read
So much
question because last year they.
What?
This year, you know.
The probability of it happening is higher, yes, because they do rotate, they definitely rotate. I wouldn't be guaranteed though, no. If there is, good for you, the rates are not that tough, so it's good, but I would not bank on it. One thing I did notice though, last year and the year before, they didn't have any differential equation plots, slope fields, which was amazing to me, because they had it from 05 to 2009 every year. In 2010 and 2011, there were no slope fields. So, I gave you Form B. That was Form B. Form A did not have it. You guys are taking Form A. Form B is the makeup. They have a makeup test, in case you missed. It wasn't on Form A. I checked, actually. All right. Good. So she's underlining already. Radius is 5 inches, right? That's a constant. Is it changing ever? No, it's not changing, so you underline it. Very good. Next. H is a function of time. Good. The volume is given a rate or changing at the rate. So if this is the change of rate of the volume, what do we write there for the change of rate of volume?
dV.
Good.
dt.
Well done.
Oh,
And it says it's given, so let's write it down, equals. You want me to, let's do this. Let me snapshot it. You can use the smart board. Drop that there. Oh no, where'd it go?
Oh my god, the colors are backing up.
What she said?
Because you guys are so...
Muy fea saliste, George, ¿por qué? Muy fea saliste.
Brown and Crayola box.
Feñita saliste.
Alright, sorry, back to the image now.
Oh, you cut off some.
Okay.
So Jasmine's starting by listing her rates. There's no need for a remember Dred's diagram, but take a look. It's given. You don't have to draw a diagram. Okay.
So all I gotta do is rinse.
So she starts with her first rate. Awesome.
The volume.
You list R again. You said R was 5. R is always going to be 5, the radius. Just list it though, yeah. Now, here's a question for you guys to think about. It's for everybody to think about. If the radius is 5, what's dr dt?
0.
0, because the radius is not what?
It doesn't have
It's a constant. Remember, if you do dv dt, it means the volume is changing, doesn't it? But dr dt means the rate of change of the radius. But look at the figure. The radius isn't changing anytime soon. The height is changing, but the radius is 5 here. It's 5 here. It's 5 here. See what I'm saying?
Yeah.
It's not a cone. So let's write dr dt equals 0. Okay, that's the one that a lot of people forget about. That's the toughest part for this problem.
That's funny because the common sense.
It is, and that's the thing. It's common sense, but you got to really think about it.
Yeah.
Okay? Which makes it not common sense, real. Now, we are trying to find this, so let's write that equals question mark.
Algebra analysis, right? What's the last part though? The volume of a cylinder, radius r, and height h is g.
Just question mark.
equation.
Oh, just put a question mark for now, because we're trying to prove that. That's what it will be, you're right. So, Jasmine's writing that we know that this is what it's going to be, but we need to show that, right? So this is our question mark right now. That's what we're trying to figure out. Do they tell us anything else?
The v equals pi r.
They give us the
Well, I mean, that's obvious.
They give us the equation, but is that it really? Okay, so let's write the equation out. V equals...
You do the derivative of that?
Yep. And what kind of a rule do you have here, guys?
No.
No, chain rule.
It's a product rule.
Remember,
Remember, this is like your A, and this is like your B? Remember that? Okay. What's the product rule, tell me?
A times under B times
plus
B
C times under A.
So let's start by listing A. Cool. So let's relist. We got list our pi r squared is A.
So,
No.
Just list it.
so pi RA.
That's so...
Pi r squared.
Right?
Okay, now, guys, stop. Come on, listen. What we have to do A times the derivative of B. What is the derivative of H?
DHDT.
dH dt. Good. There's nothing else there. Because the derivative of H is just 1 dH dt. Now, next you do plus, right? But here, before she goes any further, we're going to have to take the derivative of A, right? Which means we're going to have a dr dt at the end. But what's dr dt? And these are all multipliers, aren't they? So this next part is really just 0. Isn't that cool to see? That's the part that a lot of people don't pick up
But don't
on.
forget
It makes it so much easier now.
But don't forget you have to make d
Yes, yes. So on the other side, let's write out
I was gonna say,
dv/dt.
I was just gonna say some, what's it called?
Implicit differentiation.
Yeah, because you do.
No matter what, do we just plug in?
And now at this point, what are they asking us to find? dh dt, if we know this value, so let's do what you just said, yes?
Prove it.
Let's plug in. Let's take our value for dv dt and plug it in over here.
So that's negative, right?
Yep, negative 5 pi radical h equals pi r squared dh dt.
Just jiggle.
I'm calling you Gigolo.
Why?
Could you call me Jigaboo?
All right. At this point in time, what is the problem asking us to find again? dh dt. What's on both sides?
Five.
Pi. Pi's on both sides. We'll forget about that pi, right?
It's the head right.
Now, here's the part that gets a little bit tough. Not tough, but what's r?
R squared.
It's 5.
R is 5. That's the key here. If you forget that r is a constant, you can't get dh dt as a function of h. Look, dh dt is a function of h, isn't it? So I don't have to plug in for h. That's fine. But this r is annoying me. A lot of people forget that it's a constant. It's a constant, so plug in the 5.
So can I just put like 25?
Yes, 25 is fine.
It doesn't matter. It's gonna break off.
Okay,
Equals negative 5.
well done. And then divide by 25 on both sides.
Can you simplify this or no?
Yep, so on the next line, just simplify. 5 over 25. Do you remember that one?
Just 1 over 5.
Well done. Radical h. Get your radical.
And then dh.
Nice. And that's it. It's the exact same thing they have. Again, the problem listed it as radical h over 5 with a negative. Same thing as negative 1/5 radical h equals.
How many points you get for that?
1.
For all that work we just did, let's see.
It wasn't that bad though.
3 points.
Oh, 3
Plug
points.
in.
Very good job. Hold on. Part B. Part B. Who wants to come up and do part B?
I know I'm doing it.
You're solving a differential equation, so you're going to be integrating and getting all the constants and stuff.
Jocelyn.
Like the slope fields.
Next week, Jocelyn. Yeah.
Josh, your birthday's next week?
Friday.
Come on, come on, bro.
Oh, really? What else? What did you say about it?
Friday.
Oh, yeah, Friday. We're not doing it
Let's
then.
go, Jocelyn.
Well, save part C for Kenny. That's the harder part. You come over, buddy. Come on, I'll set you through.
Come on.
Come on, Josh. I won't leave you hanging. I promise.
Here.
Probably the first time you've ever gotten up in class. It is. I don't like doubt that at all.
Leave her alone.
Yeah, Jocelyn.
Let's clone this page. Come on.
You can clone a
I can't see you, man.
All right.
There you go.
Now, in the second part, we're given that at h equals 17, the time is 0. Right? What is that called then? Initial condition. Initially at 0, the height is 17. We're trying to solve this differential equation for h as a function of time. So this is like our slope fields. When we had dy dx and we move the stuff around. So let's start by writing out our differential equation here. And I'm going to move it down to there because that's all we need.
When they ask you to solve the differential equation for like h as a function of t, does that mean you're doing the integral? You're doing the
We're going to have to integrate. Yes. We're going to
because you're
have to
getting rid
integrate.
of like the derivative.
Exactly.
That's why I was trying to do that.
That?
So we take our differential function that Jasmine just solved for the height, and what we're going to do is actually find the height as a function of time. Okay? Now, Joss, remember from yesterday, or the other day, when we talked about slope fields. The h is over here, so what do I have to do with this h? Good, with the dt, right? So just flip-flop.
Like that, right?
Yep.
So
I know.
not negative.
You can
right?
leave the negative on the right, that's fine. Leave it with the dt, that's fine.
Oh,
Yeah, that's good, the way you're doing it.
oh, negative, right?
Yep,
dt at one time.
good, over.
They are new. They're
All right.
new for us.
Now, this part is where people get confused and they have trouble integrating this because it is a little bit tricky. What is a radical really? 1/2, right? 1/2.
Negative 1/2.
And I'll move this up to the top as negative 1/2. So let's write this as h to the negative 1/2. Again, because a radical is 1/2 power and it's in the bottom, we'll make it to the top as h to the negative 1/2 times the h equals. Now write it as negative 1/5 dt. Because now, when we integrate, watch what happens. You can integrate this and figure it out, but here, this is a constant, isn't it? So you can just simply integrate that by itself. Okay? You don't have to worry about the constant.
What are you gonna do with add-on?
It'll stay, carry down. It's like integral of 2x becomes 2x squared over 2. We'll just integrate
No,
this.
what I mean is that like you'll add a t.
We'll add a c. Now, yes, we'll tack on a t. Sure.
Yeah, then add a c after.
The integral, not add. You're not adding a t though. You're tacking on.
you're tagging on a t. You're adding a c.
Yes. Integral of h to the negative 1/2. What is that?
Negative
Over.
Over 1/2.
Good. So h to the 1/2 over 1/2. Very good. So it's a power rule. Okay, h to the 1/2 over 1/2. Okay, for now we can bring that in front as a 2.
Plus c.
I'm sorry?
Plus c.
It's not negative. Again, you're integrating this. You need to raise it up
Oh,
1.
yeah.
What's 1 above negative 1/2? Positive 1/2 over 1/2. And we can move that in front as a 2. Okay, so we'll just do this. Okay, because you divide by half, same as multiplying by 2. Continue. Now what do you do? What's the integral of dt? That's the hard part that people get stuck with. You know what it's like? It's like having a 1 here. If you integrated the number 1, what is the integral of 1?
You integrate.
What's the-
0?
You're going the other way. You're taking the derivative. What's the derivative of x? Isn't it just 1? So the integral of 1 is just x, really. So when you integrate just the dt, you're just left with t.
Okay.
Let me explain to everybody, because I know it's unclear. When you differentiate or take the derivative of x, don't you get 1? So if you integrate 1, don't you get x? And there's really a 1 here. So you're integrating on 1. So you're just going to get a t. Yes, with respect to t. Good. If you have t and you take the derivative of t, it's just 1. So the integral of just 1 is really just t. So this is going to become negative 1/5 t.
Negative 1/15?
Negative 1/5
Oh.
t.
Why is it red?
I would have felt
Because I screwed
I
up.
think off your battery, Edgar.
Plus?
What
What do you put at the end always?
Go ahead and take off your battery.
Oh, I'm going to put it right there right now.
That's right.
Is that something right?
Yes, exactly. Guys, you hear what Johnson just said? Again, say that one more time with the C.
The plus c, it can go on that side from both of them.
Good. It can go on either side, one or the other, not both. One or the
No,
other.
different, yeah.
Okay? Either side. Now, the problem gives us an initial condition that at 0, the height is 17. So when time equals 0, the height is 17, right? So if I want to find the constant, Jocelyn, I can just plug those in and solve for C, right? Or I could solve for H first and then find the constant. Does it matter? We did it both ways in class. So personally, I would solve for H first, to be honest. I would solve for H. How do you get rid of that 2 that's there?
Divide by 2.
Divide everything by 2, right? So, tell me what you would get on the next line.
You would square the 8, right?
So h to the 1/2 equals, so 1/10.
Good. Negative 1/10.
Negative
Good. T plus C. Why do I not care about the C again? It's a constant. So if I take a constant divided by 2, don't I still have a constant? And I don't know what that constant is yet. So it doesn't matter right now. Now, one thing to notice. If you solve for the constant first, and you get a numerical value, and then you go to solve for H, you do have to divide into it then. Are we clear on that? Again, if you're solving for H analytically first, and you're dividing into a constant, it doesn't matter. But if you figure out the number, because that number is a function of this. We haven't taken this into account yet, Kenny. We haven't taken into account yet, so we don't care about it.
But it's like saying you have x and...
I know, it works though. Try it both ways.
Okay.
Continuing, how do you get rid of a 1/2 power? Square both sides. So, square both sides. A 1/2 is a radical already. Undo. A 1/2 is already a radical, guys. Ready?
Oh, yeah.
A 1/2. So you need to square both.
I would do that. You're the same foot.
Square.
Good. So then just write H equals then down here. H equals, and put that whole thing in parentheses and square it.
Okay.
I don't know, hanging around too many people.
Well done. That there alone, guys, that's going to give you 2 out of the 3 points at least in this part. Now, what do we still have to do? Find the
C.
C value. What do I do then?
Plug it back in.
Plug in my,
Initial
start that over here. Just take it up, then use this side of the board
Oh, okay.
so we can all see stuff.
But why does the square stay there?
Do we plug in the t?
Yeah, it's gotta be if you
Plug in the T, yes.
So it's just 0, right?
Yeah, you're going to plug in the T as just 0. So you get 17 equals,
0
just watch it. So what is C going to be now?
Oh, radical 17.
Radical 17. Again, this 0 doesn't matter, right? So it's saying C squared equals 17. So to get C by itself, it's the square root of 17. If you didn't include this in here, Okay, if you didn't include it, it wouldn't come out to be the same answer, one. And two, you cannot distribute the square root of both. If you were able to do that, if you actually FOILed this out, which would be a waste of your time, but if you FOILed this out, then you don't have to worry about the square of the c. Okay, then you don't. But because we don't know about, I know, Kenny, just trust me on this one. Okay, so we get 17 equals, or radical 17 equals c.
What is that?
Okay? What's the last thing we should really do?
Plus or minus?
No, oh, well, it is plus or minus, really.
Plug
I'll explain why it's not one or the other.
Plug the
remember.
value for c back in.
Yeah, plug it back into the original. Write it down.
Which actually you
can't have a negative
probably won't get a point if you don't do that.
All right, let's discuss why it's not negative 17 or negative radical. Because again, you're right. There really is a plus or minus
There's a
here.
function of time.
Yeah.
Look at the initial condition. What's the initial condition tell us?
0 to 17, so it can't be.
It's positive there. It's positive, right? So when I plug in a 0, I want to get a positive 17 out. Now, you might argue with me and say, oh, well, you know, if this is even negative, then you're going to square it, and you're squaring a negative, so it's positive anyway. But when you see a positive here as your initial condition, use the positive root. It's an easy way to remember it. If you saw that the initial condition had a height that was negative, you would use the negative square root there. Okay, it's going to affect that problem there. It doesn't affect this problem much, but you have seen it in other places. Let's look at the last part, Kenny.
Yeah.
This is for you to do.
Yes.
And what time is the coffee pot empty, Kenny?
Are you doing derivative for the second one? Or no? I don't know. I thought you put h3. No. Yeah, I know. I thought you put h0.
Let's make it so much easier, guys. What did we just solve for? We solved for what?
When t equals 0.
Wait, what did you say, actually? Sorry, let me go back. What did you just say before that?
h0.
Yeah, that's all. Very good. Because, what is it? Sorry, I think you said take a derivative, didn't you?
Originally,
Originally, yeah, originally. It's just set h to 0. Because think about it. If the coffee pot's empty, what's the height of the water in the coffee pot? It's 0. There's no height. So when this height is 0, it's at the bottom. So set h to 0. So Kenny, I know it's not that tough, but the thought process is the tough part. So tell us, Kenny, what is the time? At what time is the coffee pot empty?
No, I think you put, I don't know. So we use our refiner, right? So then we.
And it's not, again, you're not like setting a derivative equal to 0, finding critical points. It's just the height is 0 when the coffee pot's empty. So set it equal to 0.
No, but I was just thinking, could you do like a radical root? No, that'd be too much. No, because I was wondering to get.
Why don't you just write it down first?
Okay, that's good. That's good. Don't worry.
It might help you.
We're working our way.
Now, please somebody tell me, does a squared matter?
No.
Because what's the square root of 0 when you take the square root of 1? It's still 0. So don't even worry about the square. See that? Because you're going to take the square root of both sides, right? To get rid of that square.
That's what I said, yeah.
So don't even do it. Just cross it off. I wanted you to write it though.
But okay, so I got you.
Okay?
All right.
But again, if you take the square root of both sides, the square drops off.
Oh, that's good.
Why don't you move the negative 110 t over?
What?
Solve. Move it over. Good.
No, okay, okay. I see what you mean.
Here, I get it now. I didn't get the anchor part the whole. I'm like, what are you guys talking about, anchor? It's T. No, the T looks like it was an object. Yeah, the first one. What about units here?
I don't know. It is what it is?
Time.
Yes, it is? Oh.
Seconds, minutes, whatever it was, I forget. Look at the part. What does it say in the beginning?
I don't know. I don't know what it was. Son of a gun.
Seconds.
Mr. Howe, did the AP students get a special lunch?
What?
Do we get a special lunch today?
Yeah.
Did you get a spot? Yeah, we're doing a
prayer/lunch.
Yeah, prayer/lunch. Miss Turner should have put on the announcements this morning.
Yeah, no, she told me this morning.
Oh, okay.
What are they giving us anyways?
Yeah, we're going. Oh, she went to your classroom and told you? So instead of going to lunch, guys, what we're doing today, we're all going to the chapel for a short prayer service, and then we're going to have a lunch in Samuel Hall.
What we getting?
I have absolutely no idea. I really don't know.
Wait, how's it?
I'm not sure.
How are you even recording?
I am recording, yes.
No, you're not. Oh
think
my
I
god,
am.
you weren't recording.
Good.
Oh my god, you're
You got the way to do it.
I really forgot to record.
Yeah.
I got none.
Such a bunch of jokes.